Hi everyone, welcome to my Core 2 OCR June 2013 paper. We're going to look at question 5. Question 5 is about arcs and sectors, so you need to know off by heart the formula for arcs and sectors. Now if we read the question, it tells us that BAC is a sector of a circle. Okay, so let's think about what that actually means. That means we had a circle and we cut a bit out. So hence, these two lines are both radii, okay? So if we think about that, this straight line along here is 16, and we should already be thinking of finding missing values. This length has to then be 9 centimeters. Carrying on with the question. The angle BAC is 0.8 radians, which is labelled. The length AD is 7 centimeters, which is also labelled. Now, part I says find the area of the region BDC. So we're talking about this. This is not a sector. Okay, this line is clearly longer than the other one. So we can't use the sector formula, even though that we know that this length is 9. What we need to do is find the total area and then take away the area of the triangle, which will leave us exactly what we want. Okay, so that's our plan of action. So, area of a sector, we need the formula. And I like to use little diagrams when doing this so that we don't have to write out sector. We draw a little sector. A half r squared theta. You need to learn that. So, our radius is 16. So it's a half times 16 squared times by 0.8, and if you put that straight into your calculator, 102.4, and that is centimeters squared because we're talking about area. Now if we want the area of the triangle, we don't know the base and the height, so you can't use your GCSE formula. We need to use our A-level formula, or actually A star GCSE also. And the way I think about this formula is all you need is two lengths and the enclosed angle. Okay, so I think instead of as a triangle of this shape, doesn't matter which way around it is, if you have this length, and the angle between, that gives a triangle, and you can find the area of the triangle by doing a half AB sine C. So in my way, we're just going to do a half times one length times the other length times sine of the angle. Now you need to make sure that your calculator is in radians, so you need to change it to radians if it's not already in it, because we are going to be doing sine of 0.8. And the area of the triangle is going to be, just put it in my calculator, 40.17 to 2 decimal places. So if we want the remaining area, when we take away the triangle, we have the area is going to be 102.4 take away 40.17, which gives us 62.2 to 3 significant figures. Okay, so that is the first part of the question done. The second part of the question is talking about the perimeter of the same region. So for perimeter, we need to find this length. We already know this is 9, and we also want this unknown length here, which we might as well call x. So let's clear off everything else that we've been working on and look at finding the perimeter of the shape BDC. Now if we think about this triangle, this is what we're going to use to find the missing length x. Okay, so we've got the angle 0.8 radians, 16 and 7. And what you're going to have to use is the cosine rule. The cosine rule says a squared equals b squared plus c squared minus 2bc cos a. where A is the angle you know, which means that this has to be A. And opposite the angle is where you label the corresponding length. So this is A, and the others don't matter which order. We can say B and C. So now let's substitute into our formula. The unknown A, or as we call it X, equals 16 squared plus 7 squared, take away 2, times 16, times 7, times cos of 0.8, making sure you're in radians. If you put all that into your calculator, you're going to get 148.937, etc. Now that's for x squared, so you want to square root your answer, and that is the value of x, 12.2 to 1 decimal place. Okay. Now what we need to do is find the arc length. The arc length we can find by using the formula that it equals r theta. So it's going to be 16 times 0.8. 16 times 0.8 is 12.8 centimeters. Now we just add up all these values to get the total perimeter. So we're going to do 9 plus 12.8 plus 12.2, and that gives us 34 centimeters. And that's your answer. I hope this has been useful and you've understood my diagrams.